Section 2.1, Complex Numbers. This video will help you recognize and write complex numbers and use the complex conjugate of a number to simplify expressions. Let's start here with complex numbers. And we're going to start because we need to recall a couple things here before we start with complex numbers. So I want you to, if you can, from memory, write down what imaginary number is and kind of what that represents. And I'd also like you to write the quadratic formula. So go ahead and pause your video player here and start right out and see if you can, from memory, write down these two things. If you can, great. If you can't, or you get close, no big deal. But it helps to try first before I show you. All right, let's take a look. The imaginary number I, for imaginary, represents the square root of -1. And remember that we cannot take the square root of a negative number and get a real number. So then that's when we come up with imaginary numbers, and the imaginary number I comes into play. All right, the quadratic formula, and again we use this when we're solving a quadratic equation up here. So we've got some generalized form here, ax squared plus bx plus c is equal to 0. And notice I included this here that a can't be 0 because notice if a was 0, this x squared term wouldn't be there and we just have a simple linear equation. So we wouldn't use the quadratic formula to solve that. But if a is non-zero, then we want to go negative b plus or minus the square root of b squared minus 4ac all over 2a. And now we use the quadratic formula when we're solving a quadratic equation, like one in this form, and we can't use factoring to solve that. A lot of times with a quadratic equation like this, we can go ahead and factor that out to find the solutions. But a lot of times those quadratics won't factor evenly, and so that's when the quadratic formula comes into play. So we will use both of these ideas as we're going through this lesson here in complex numbers. Complex numbers contain both real and imaginary numbers, and they're written in the form a plus bi, or you could also write it a minus bi. So notice why we call them complex is because we have both a real number here, in this case a, plus an imaginary number here, some number times I, or a minus some number times I. And here's an example of a complex conjugate here, 2 plus 3i. Conjugate of a complex number. The complex conjugate of a plus bi is a minus bi. So those two are complex conjugates of one another, and then we could say the same is true in reverse. If we take a minus bi, the complex conjugate to that is a plus bi. And the reason we're concerned with complex conjugates of a number is something really nice occurs when we take two complex conjugates and multiply them together. If I take the product of a plus bi and a minus bi, the middle term drops out. Remember when we have plus or minus the same term, when we're multiplying two binomials, the middle term will drop out. Well, with these conjugates here, the middle term drops out, which means I drops out entirely, and we're left with a real number, whatever a squared plus b squared is. All right, let's take a look at an example and see kind of how that all unfolds here. So I'm looking at this example here. I'm going to FOIL and multiply these things together. So first I'll distribute my 2, which would give me 4 minus 6i. 6i. Now I'll distribute the the 3i. So I'd say, all right, 3i times positive 2 would give me plus 6i. And then 3i times 3i would be, careful here, let's see, that's a positive times a negative. So I would have a negative 9i squared. All right, so let's kind of talk through that just a little bit. It's going to be negative because I got a positive term times a negative term. And I'm taking the 3 times 3, which should give me 9. And then I times I is I squared. Let's kind of go over here for a side moment. Remember, I is the square root of -1. So if I take the square root of -1 and then square it, I will get just -1 as my solution there. So really right here, this -9 times I squared. Well, I squared is really just negative 1. So really I'm going to get negative 9 times negative 1 here, which would make this then a positive 9. Notice too that the two middle terms are going to drop out here, the negative 6i and the positive 6i. So what I'll have left is I'll have 4 plus 9 to give me the real number 13. Okay? Just like we discussed right here. A plus bi times a minus bi gives me a squared. Notice here, 2 times 2. 2 squared is 4. And 3i times 3i, negative 3i, is positive 9. All right. Let me erase this over here. And why don't you guys go ahead and try this practice problem here. Go ahead and pause your video player now and multiply this out. And go ahead and multiply it out because you want to follow the details here. We are going to be multiplying some conjugates and some other complex numbers together, and you're going to want to pay careful attention to how this works. Go ahead and pause your video player and answer this practice question, or simplify this practice question here. All right, let's take a look. So first we'll distribute the 5, which would give us 25 minus 20i. Then I'll distribute the 4i here, so that's going to be plus 20i. And then 4 times negative 4 will give me negative 16. And then I times I will give me I squared. So let's simplify this then. 25 negative 20i plus 20i is 0. And remember, this is going to be negative 1, so negative 1 times negative 16 would give me plus 16 there. And let's see if I can do this here. 31, 41, positive 41 when I add those together. Okay, so here is where these complex conjugates really come in handy here. It's because we use complex conjugates to rationalize the denominator when the denominator contains a conjugate number. So I've given you two fractions here. Both going to have a practice. I'm just going to have you go ahead and try these. I'll give you a little hint and then let you try them. But notice in both of these cases, we have a square root in the denominator. Here, the square root of negative 1, that's what I is, and that's in the denominator. And remember, we don't want to have any square roots in the denominator. So we call this rationalizing the denominator, meaning we need to get a rational number down here, not some sort of square root or some sort of irrational number in the denominator. So if you remember how we do that, we multiply. And in this case, what we want to multiply by is we want to multiply the top and the bottom of the fraction by the same thing. Because if we do that, we won't change the value of the original fraction. And what we want to multiply by here is the complex conjugate. So multiplying top and the bottom by the same thing, because really this is kind of a fancy form of the number 1. If we took 2 plus 4i divided by 2 plus 4i, we get 1. So we're taking this fraction and multiplying it by a form of 1. So we're not changing any values here. But when we do this, what we get then is we're going to get a nice real number in the denominator. So go ahead now and pause your video player and multiply this through and get that one answered. Then maybe play it back and see it, and then we'll go ahead and try this practice question, the second practice question here. All right, so let's take a look and see what we get. We'll kind of work our way down in both the numerator and denominator here. So in the denominator, I'll start with the top. I'm taking this guy times that guy. So let's see, 3 times 2 is 6. 3 times positive 4i is going to give me positive 12i. 2i times 2 is going to give me positive 4i. And then 2i times 4i would give me 8i squared plus 8i squared. Get my plus back in there. All right, the denominator. I'm going to take 2 times 2 is 4. 2 times positive 4i is positive 8i. All right, negative 4i now. Negative 4i times 2 gives me negative 8i. And then negative 4i times positive 4i gives me negative 16i squared. All right, let's simplify this down now. In the numerator, let's see. This is going to be 6 plus 12i plus 4i is going to be 16i. And then positive 8i squared, well, remember, I squared is negative 1, so that will really turn this into a negative 8. All right, we still got some more simplifying to do up here, but let's go to the denominator as we're going here. Let's see. 4 is going to stay 4. Positive 8i, negative 8i, those are gone. Now remember, this is going to be a negative 1, which would negate that negative, so this is really going to be positive 16 down here. Okay, let's see if I got just enough room to finish this here. All right, so in the numerator now, I have 6 minus 8, so that's going to give me negative 2, and I write the real number first, plus 16i. And now in the denominator, I have 4 plus 16 to give me 20. One more step here. I can simplify this guy. Notice there's an even number. These are all even numbers, so I could divide a 2 out of every one of these things. So this would be negative 1 plus 8i divided by 10. And there's my final simplified answer. All right. Go ahead now, pause your video player again and answer this next practice question. And when you get done, hit play to see how you did. Okay, I'm going to erase some of this to make just a little bit of room here for myself. All right, so we want to multiply by the complex conjugate of this denominator. So that's going to be 6 minus I. Same thing to the top. All right. Okay, I distribute the 5. That's going to be 30 minus 5i. And then negative 3i times positive 6 will give me negative 18i. And then negative 3i times negative I would give me positive 3i squared. Denominator, 6 times 6 is 36. And then I'll have minus 6i. Distributing the I now, I'll have plus 6i. And then positive I times negative I would give me negative I squared. All right, let's simplify this down. So this guy right here is going to really be a real number here. So I squared is negative 1. Negative 1 times positive 3. This is really a negative 3. So I'm going to combine this negative 3 with that positive 30, which would give me 27. And then I have negative 5i and a negative 18i would give me negative 23i. The denominator, I have 36. Negative 6i and positive 6i drop out. And then I have negative I squared. Well, remember, I squared is negative 1. So if we take the opposite of negative 1, that's actually plus 1 there. Let's give myself a little room there. And let's see. In the numerator, that's simplified. 27 minus 23i. And in the denominator, I'll have 37. I could look for a common factor here, but they aren't any. 23 is already a prime number, so 37 is also a prime number. So we're not going to be able to factor or simplify this one down. So that's our final simplified form of rationalizing this denominator. All right, the principal square root of a negative number. So whenever we're taking the square root of a negative number, we can write it in its principal form, and that is just simply by taking this negative 1 out front, writing it as I. So remember, we could write this square root of negative b as the square root of negative 1 times b. And when we take this square root of negative 1 and factor it out front, we can write it as an I. That's where that I comes from. And so when performing operations with square roots where there's a negative number inside the square root, we first always express any negative square roots in terms of I before we do any operations at all. If you don't follow this, you can get the wrong answer, which we'll show you in just a second here. But all right, so let's say here in our example, we're going to try to perform this operation where we have negative values under the square root. So the first thing we want to do is we want to factor these i's and bring them out front. So let's see. So I would write this as I times the square root of 16 times I times the square root of 64. Once I get it in that form, I'm ready to go ahead and simplify this dang thing down. So I, and then that's going to be times 4 times I times 8. So multiplying this stuff together, let's first multiply our real numbers together. The 4 and the 8 would give us 32. And then the I times I would give us I squared, which then will give us I squared is going to be -1. So -1 times 32 would give me an answer of -32 for that answer. So this answer is correct. So this is the right way to do it. Let me show you, if we had not factored those i's out front, we would have gotten the wrong answer. So if we went to do this and we multiply these things together, which we can do, if these were positive numbers in here, we can just go ahead and multiply these two together to get to our answer. If they're negative numbers, we can't, and you can see why here in a second. So I'll take -16 times -64, okay, and that would give me then positive, square root of positive 1024. Notice, because we took the negative times the negative, we're getting a positive answer. Now when I take the square root of that, that's going to give me positive 32. So notice that is the incorrect answer. So we would say, okay, don't do this. That's a bad idea. So anytime we're performing any sort of operations where we have negative values under the square root, we always want to first express everything in terms of I in its principal square root form. Okay. So I have a couple practice questions here for you, and notice we got a quadratic formula, a quadratic equation in both of these guys. So we would use potentially factoring to solve these things, or the quadratic formula. I can tell you that I picked them out specifically so that we would have to use the quadratic formula here, and again, even more specifically, so that we're going to get complex number solutions to our answers. So we'll go ahead and use the quadratic formula to solve these things, and when you get to the end, we're going to be trying to take the square root of some negative numbers. So these answers, you're going to get some complex conjugates. So go ahead and write those out, and also make sure to be careful to see if you can simplify any of those, and also check to make sure to see if you can simplify any of those complex conjugate answers. Alright, let's take a look here at the first one. So writing the quadratic formula up here, remember, is -b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so in the first one here, a is going to be 1, b is going to be -6, and c is going to be 10. So let's see. So -b would be +6 plus or minus the square root of b squared. Well, -6 times -6 is +36, minus 4 times a, which is 1, times c, which is 10, all over 2a. Well, a is 1, so that's just divided by 2. All right, let's simplify what we have here. So I have 6 plus or minus the square root. This is going to be 36 minus 40. So 36 minus 40 is going to give me -4 all over 2. Now, notice we've got a negative value under the square root, so we want to quick pull the I out front before we perform any other operations. So 6 plus or minus I times the square root of 4 all over 2. Alright, well, we can take the square root of 4, that's going to be 2. So we're going to get 6 plus or minus 2i all over 2. And notice we can go one more step here. Since 2 is a factor in all of those cases, we can write this as 3 plus or minus I all over 1. So 3 plus or minus I. It's going to be our answer there. Alright, let's take a look at the next one now. So here I have that a is equal to 2, b is equal to 2, and c is equal to 3. So we've got -b, so -2 plus or minus square root of b squared, which is 4, minus 4 times a times c all over 2a, which is 2 times 2. Alright, let's see how this one simplifies. So -2 plus or minus the square root Let's see what this is. So that's 4 times 2 is 8. 8 times 3 is 24. So we're looking at 24 in there. So I have 4 minus 24. Well, that's going to give me a negative 20 in there, all over 4. Okay, before we perform any operations, let's factor that I out front. So negative 2 plus or minus I times the square root of 20 over 4. We could start dividing out a little bit here, but we can also simplify this 20. There's a perfect square hiding in there, so I'm thinking 20 as 4 times 5. I can take the square root of 4 and pull that out front. If I take the square root of 4 and pull it out front, it'll be 2. So I'd have this, negative 2 plus or minus 2i times the square root of 5 all over 4. Okay, one more step here. Notice I could divide a 2 out of all of these terms. This is a term here, this is a term there, there's a term there. We could divide a 2 out of each of those, so it would look like this. Negative 1 plus or minus, this 2 right here will divide out. So I'll be left with I times the square root of 5 all over 2. So I divided a 2 out here, a 2 out there, and a 2 out there. All right.